To understand chemical reactions, we need to understand a little bit more about atoms and molecules, and how those things work. So let's just take elements. Atoms are just elements that you would find like on the periodic table. And let's see if you recognize what some of these common abbreviations for these elements mean. So for example, C is for carbon, H, hydrogen, O, oxygen, N, nitrogen, P is going to be for phosphorus, K is for potassium, S is for sulfur, Na is for sodium, Ca is for calcium, Mg is for magnesium, and Cl is for chlorine. This is a generic atom, and let's take a look at some of the parts. A is pointing to an electron. Electrons are negatively charged, and electrons will orbit the nucleus of the atom. B is pointing to a neutron. Neutrons have no charge, but they do have weight or mass. Electrons are too small to have any mass. C are protons. So protons and neutrons make up the nucleus. That's where the atom gets its weight or mass. Electrons orbit the nucleus. Now you'll notice that there are 4 protons. They are positively charged. There are 4 electrons. They are negatively charged. So those two things cancel each other out. An ion is when you have an extra electron or when you're missing an electron, so that the atom has a charge, either positive because you're missing an electron or negative because you have an extra electron. Take a look at these 3 elements. So carbon is C. The 6 at the top of that little diagram is speaking to the number of protons. So that's the atomic number. So 6 is the protons, the positive charge. 12 is the atomic weight. How much does it weigh? So if we have 6 protons and we know that neutrons contribute to the atomic weight, then I've got 6 protons, some number of neutrons, but the overall weight is 12. So you ask yourself the question, 6 plus what gives me a weight of 12? And the answer is 6. So I have 6 neutrons. If I have 6 protons and it's not an ion, then that is going to have 6 electrons because the positives and negatives will cancel each other out. Look at oxygen. Oxygen has 8 protons. That means it has 8 electrons in order to have no charge. 8 plus what is a weight of 16? And the answer is 8. So I've got 8 protons, 8 neutrons. Now, an isotope just means we have extra neutrons. So for example, carbon 13, carbon 14 just has extra neutrons. And you may have noticed that we can add or take away electrons. That makes an ion. We can add or take away neutrons. That makes an isotope. We cannot add or take away protons because that will make it a different atom. Hydrogen has an atomic number of 1. That means 1 proton, 1 electron. You'll notice that the atomic weight is 1, so we don't have any neutrons in that case. Take a moment and draw an oxygen. That means draw the nucleus, protons and neutrons, and draw the electrons going around the outside. You'll notice that there were 2 electrons in that first circle, and then that energy level is full. Then there's up to 8 that can be in the second circle. Not all atoms have 8 in that second circle, but when they do, then that level's full, and we go to a third circle that might have 8. So take a moment, draw an oxygen, and then take a moment, draw a hydrogen. So pause the video, go ahead and draw them. Now here's a difficult question because most of the human body is made of water. The chemical formula for water are 2 H's, 1 O. But when you look at the percent by weight in the human body, you'll notice that oxygen has a very high percent and hydrogen has a very low percent. But we have 2 hydrogens for every oxygen. Like, how is that even possible? How can the oxygen be a higher percent than hydrogen where there are 2 hydrogens for every oxygen? Give that question some thought. See if you can come up with a good answer. Before we go on, just take a moment and write down 5 things you know about atoms. So 5 facts about atoms. Just take a moment, write them down. Pause the video, write it down. Here I have a sodium and a chlorine. The sodium atom and the chlorine atom. These are going to join together. And the way they do is they will form a chemical bond. Well, how do they do that? One way to form a chemical bond is to give an electron or to take an electron. It makes an ionic bond. It makes an ionic bond because the atom becomes an ion. By either giving away an electron, it becomes an ion, or taking an electron, it becomes an ion. So you'll notice in the sodium atom, we have 2 electrons in the first energy level. That makes it full. In the second energy level, we have 8 electrons, and that makes it full. In the final electron level, we only have the 1. That means there's 7 vacant spots. Atoms that are stable have all their energy levels full. So now sodium has this extra electron that it needs to get rid of in order to have some stability. Chlorine is the perfect complement. You'll notice that chlorine has 2 electrons in the first energy level, 8 in the second, and then 7 in the third. If chlorine could get an 8th electron, then it would be stable. So sodium gives the electron, chlorine will take an electron, and now we have an ionic bond, a chemical bond formed between 2 atoms that are now ions because of the electrons. Here are 2 oxygen atoms that have formed a chemical bond. Again, they're trying to get 8 electrons in their outer energy level. That makes that atom stable. These 2 oxygen atoms are sharing their electrons. They're not giving or taking them, they're sharing them, which is called a covalent bond. So co just means share, like cooperate. They're sharing them. So you'll notice there's 2 electrons in the first energy level. And if you count the second one, 1, 2, 3, 4, 5, 6, 7, 8, the yellow oxygen is sharing 2 of the electrons with the green, and together that makes them have 8. So it's stable. It's a very strong bond. Covalent bonds are much stronger, generally speaking, than ionic bonds. So a covalent bond can be a strong bond. Consider this question. Electrolytes are ions that the body uses to maintain electrical charges. Which type of chemical bond would yield electrolytes in a sports drink? So the key word here are the ions. Would that be a chemical bond that is covalent or that is ionic? What do you think? See if you can answer some of these questions. The atomic number is the number of. If you guessed protons, you guessed correctly. An ion has gained or lost. If you picked electrons, you picked correctly. An ion has lost, and again, electron is the correct answer. To find the atomic mass, you have to add what 2 things? If you picked protons and neutrons, you picked the correct answer. If you're sharing electrons, type of bond is covalent. What I'd like you to do is think of your left hand as ionic. Think of your right hand as covalent. All right, so sharing electrons, is that going to be a lean toward the ionic side, left side, or the right side, covalent? So sharing electrons, lean to the right. Weak bonds, lean to the left. Creating ions, lean to the left. Strong bonds, lean to the right, covalent. Giving or taking electrons, lean to the left. That will be ionic.